Among 703 randomly selected workers, 61% got their job through networking. So this was a sample that was randomly surveyed, and these were our results. 61% get their job through networking. Now, at the 1% significance level, let's test the claim that most workers get their job through networking. So first, I'm going to list what the alternative and null hypothesis is. Starting with the alternative, we will look at the claim. The claim is that most workers get their job through networking. Excuse me. So this is a claim about the population proportion, and we are saying that most people, so greater than 50% of the people, get their job through networking. Once we've established the claim, it does not have equality. It belongs to the null hypothesis, or to the alternative hypothesis. Then we can write in the alternative hypothesis. So the alternative hypothesis is that less than or equal to 50% of the people get their job through networking. Then we'll check the requirements for using the Z proportion test. First, the sample observations must be from a simple random sample. And we are told in the problem that 703 people were randomly selected. Okay. Then we'll check that the conditions for the binomial distribution are satisfied. There is a fixed number of trials, in this case 703. They are independent. There is only success or failure outcomes. Either they got their job through networking or they didn't, and the assumed probability of success will stay the same for each one of the workers. Then we have to check that the number of people in the sample times the probability is greater than or equal to 5, as well as the number of people times the probability of failure is greater than or equal to 5. Now, since both of these, the probability of success is 50% and the probability of failure is also 50%, so we can say that this is equal. Oops, let's get out of there. Delete that. Okay, down here. There are 703 people, and the probability of success and failure are both 50%. So clearly 350 is greater than 5. So the requirements are met, and now we can continue with the test. So the sample proportion is taken from the problem. It said 61% of people got their job. So we'll type in 0.61 there through networking. Probability of success is 50%, and the probability of failure is also 50%. After that, we'll move to calculating the test statistic. So the numerator is p hat minus p. So we come here and remember to open your parentheses. P hat is given in this cell, and then we'll subtract off p, which is given in this cell, and close your parentheses. Then we will divide that by the square root. We need the square root function, and we will be multiplying p times q, and then dividing that by n. Now, n we didn't write down in a cell, so we'll just type it in, 703, and we can hit enter. So there's our test statistic, 5.833. All right, next we need to determine the critical value. Now this is a right tail test because remember up here, the alternative hypothesis is p is greater than 50%. Now what's our significance level? It's the 1% significance level. So if we were to calculate the critical value here, this is equal to the normal. We'll use the inverse. This will be the standard normal inverse. The probability here is 99%, okay, because this is calculating area to the left. So 2.326 is our critical value. Then we can calculate the probability. So what is the probability that x will be greater than 5.833? Well, that is the same as using the complement, 1 minus the probability, and again we'll calculate the the norm. We'll use the normal, standard normal distribution here. The value of z that we are looking for is 5.83, And yes, we want this to be cumulative. Okay, and we click OK. All right, so you can see there that this number is effectively 0. All right. So now let's make some comparisons. We can make a decision on the test based upon the critical value, or we can make it based upon the p-value. So if we come over here, we can see that the test statistic here, 5.833, is greater than the critical value, and therefore it's in the critical region. And since that is in the critical region, then we will reject the null hypothesis. We can also look at the p-values. The p-value here is effectively 0. So it is less than alpha. Alpha, remember, up here is 1%, so 0.01. And since the p-value is less than alpha, we reject the null hypothesis. And once we have that, then we can make the interpretation of this. At the 1% significance level, there is sufficient sample evidence to support the claim that most workers get their job through networking.